Asphalt mixture performance tests help agencies, contractors, and researchers improve asphalt performance and prolong service life of flexible pavements. This video is part of a series on asphalt performance testing and demonstrates the semicircular bin test, or SCB, at intermediate temperatures. The data from this test can be used as a performance indicator to determine an asphalt mixture's cracking resistance at climatic intermediate temperatures. This test is based on ASTM D8044-16, standard test method for evaluation of asphalt mixture cracking resistance using the semicircular bin test at intermediate temperatures. All ASTM and AASHTO standards mentioned in this video are voluntary standards and are not required under federal law. The SCB test uses a half-disc test specimen with different notch depths cut parallel to the loading and vertical axis. The notch depths are 25 mm, 32 mm, and 38 mm. Load is applied along the SCB specimen's vertical radius, and the load and load line displacement, or LLD, are measured during the entire duration of the test. The load is applied in a way to maintain a constant LLD rate of 0.5 mm per minute for the duration of the test. Equipment and supplies for this test include axial loading device, precise control and data acquisition system with a sampling rate of 10 Hz or more, LVDTs, environmental conditioning chamber, PTFE sheets, SCB test fixture, 4 SCB test specimens at each notch depth of 25 mm, 32 mm, and 38 mm, dummy sample with temperature probe, masonry saw. Laboratory prepared test specimens should be long-term oven conditioned as suggested in AASHTO R30. Field cores do not need to be conditioned prior to testing. Fabricate at least 3 SGC samples with a diameter of 150 mm by 120 mm thick using a superpave gyratory compactor. Target air voids to 7% plus or minus 0.5% according to ASTM D6925. To prepare the semicircular shaped test specimens, cut a 150 mm by 120 mm SGC sample into 2 identical 57 mm thick circular discs from the middle of the SGC sample. Cut the disc into 2 identical semi-discs along its central axis. The height or radius of the 2 samples should be within 1 mm of each other. For the field cores, the dimensions of the cores should be 150 mm in diameter and between 38 and 60 mm in thickness. If the thickness of the core is greater than 60 mm, it should be trimmed to 57 mm and cut similar to the laboratory prepared test specimen. Next, cut a straight vertical notch along the axis of symmetry of each semicircular specimen. A minimum of 4 semicircular specimens should be tested at each notch depth of 25, 32, and 38 mm. The notch width should be less than 3.5 mm. Determine the test temperature based on the climatic intermediate performance grade temperature as described in the standard. Place a dummy specimen with a temperature probe in the chamber at the same time as the test specimen to determine when the test specimen reaches the target testing temperature. If a dummy specimen is not available, condition the test specimen for 2 hours plus or minus 30 minutes. Inspect the fixture to ensure all contact surfaces are clean and free of debris. Place PTFE sheets or pads on the bottom support roller to reduce friction between the specimen and testing fixture. Mount the specimen in the testing device, ensuring it is centered, level, and makes uniform contact on the support rollers. To conduct the test, enter the information in the test controller. Set the test temperature of the environmental conditioning chamber to the specified test temperature. Allow the chamber to equilibrate. Once the test temperature is reached, apply a 45 Newton preload to the specimen for a maximum duration of 30 seconds to ensure the sample is seated properly. Verify proper level and position, then release the load. Now the test is ready to start. Apply load to the specimen in displacement control at a rate of 0.5 mm per minute. Ensure that time, force, and displacement are measured and recorded at a sampling rate of 10 Hz or more. The test can be terminated when fracture failure occurs or when the applied load decreases to 25% of peak load. When the test is complete, remove the specimen. The process should be completed for each notch depth. The load and vertical deformation relationship at each notch depth is recorded. Analyze the test data and calculate the strain energy for each test specimen at each notch depth. Compute the critical strain energy rate as described in the standard. This engineering property is a cracking performance indicator of the asphalt mixture at intermediate temperature. An SCB test data report should include the following parameters: asphalt mixture type, test temperature in Celsius, specimen air voids in percentage, specimen thickness in millimeters, notch depth per sample in millimeters, strain energy to failure per notch depth in kilojoules, average strain energy per notch depth in kilojoules, standard deviation of strain energy per notch depth in kilojoules, coefficient of variation of strain energy per notch depth percentage, coefficient of determination of standard deviation of U versus notch depth percent, and J integral value in kilojoules per square meter. For more information about asphalt testing procedures or other pavement testing resources, visit fhwa.dot.gov.